Well, living environment fans and friends, what a wonderful Valentine's Day it was. I hope yours was full of love. And anyway, now it's back to the more realistic pain of everyday school. Not really. Anyway, yeah, let's do today's Bellringer. Then, of course, we have an Ed puzzle lesson. Then today's book talk. And our book talk is on Stiff, Chapter 2, which is all about the market for dead bodies, and especially in the anatomical academia circles, how things have changed over time and what people were willing to do and not willing to do. It was a fascinating read, and I can't wait for you to tell me about it. Let's do the Bellringer. All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. Oh, I was just reading this great book, Netflix and Cell by Addie. Yeah, all about cell cycle. Look how good that is. Anyway, just a reminder that your mini books are due today. They're due today. All right? And of course, your mini book is all about the cell cycle. And let's review cell cycle with our test coming up in a couple of days. G1, S, G2, prophase, metaphase, anaphase, telophase, cytokinesis. Now you tell me. Yeah, power of the fist, baby. Power of the fist. Of course, also on the test is going to be transcription and translation, right? And we know that transcription is done in the nucleus. It's when you go from DNA to messenger RNA. mRNA. See, mRNA, 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 right? And you get what's called a set of codons, which is a copy of a gene. So messenger RNA has a copy of a gene, and the copy is written in these codons. Codons are groups of 3 nucleotide base letters. Okay? And then, of course, we studied the chart, and the chart tells us what amino acid pairs up with these 3 letters. Now, what's interesting is that methionine always starts every protein. Every protein on Earth starts with methionine, so that's pretty interesting. And then all the ones after it can be different. And then we also know that there's a code that tells the cells to stop, right? And that's called the stop codon. There's like 3 different ways to tell the cell to stop. Right. So this is what happens during translation, is when you go from RNA to protein. And of course, these monomers of amino acids are stuck together with what we call peptide bonds. Right? The monomers make up the polymer. The monomers are amino acids. The polymers are proteins. Right? Some good old vocabulary. Remember, there's only 20 amino acids to make up all the proteins that you need. So think of the 20 amino acids are like 20 different Lego pieces that could be put together. You can put them together in almost any order. And because they're also got charges and they're different sizes, they tend, as you build them, to fold up on each other. And that's what gives the protein, these thousands of amino acids long, gets this distinct shape, right? And remember we talked about enzymes? Enzymes needed to be the perfect shape because they had their, what was that called again? That space where the substrate bound to? Good memory. Yeah, it was called the active site. And hey, what's something that might limit the rate of enzyme activity? That's right, we studied that. pH, certainly, especially acidic pHs will denature proteins and will limit how well they react. So very good. You guys remember a lot of stuff. You know, regardless of what you think, you've learned something this year. Keep it up.